Multistage transistor amplifiers. In a multistage transistor amplifier, there is more than one transistor amplifier circuit exists. It's like that input is there is a first stage and a coupling, and connected to the next second stage, coupling, third stage, output, etc. So this is a 3-stage transistor amplifier. In a multi-stage amplifier, there is different stages. The different stages are coupled by some coupling. A coupling is mainly used to transfer AC output of one stage to the input of next stage, to isolate the DC condition of one stage from the next stage. There are 3 different amplifiers. When we use RC coupling, it is called RC coupled amplifier. When you use transformer coupling, it is transformer coupled amplifier. If it is direct coupling, it is called direct coupled amplifier. Decibel power gain APdB in decibel is 10 log AP, that is 10 log P out by P in, output power by input power. Decibel voltage gain AVdB is 20 log AV. 20 because power is I square R. Bandwidth, the range of frequency over which the voltage gain is equal to or greater than 70.7% of maximum gain is known as bandwidth. So this is a graph connecting gain and frequency. This is called frequency response of the amplifier. This GM is the maximum value. This is the 70.7% of GM. So this is F1 at this point F1, this is F1 and F2. F1 minus F2 is known as bandwidth, where F1 is lower cutoff frequency, F2 is upper cutoff frequency, and FR is the resonant frequency. At resonant, it have GM maximum value. Suppose GM is 100, so this value is 70.7. So fall in voltage gain is 20 log 100 by 70.7. This is equal to 3 dB, or we can say this is the 3 dB point. This is 3 dB point. Therefore, bandwidth can be defined once again as bandwidth of an amplifier is the range of frequency at the limits of which its voltage gain falls by 3 dB from the maximum gain. RC coupled transistor amplifier. In resistance capacitance coupled amplifier, the different stages of the amplifiers are coupled with a capacitor. This is a 2-stage RC coupled transistor amplifier. This is the first stage, this is the second stage, and 2 transistors. That first stage is coupled with the capacitor CC. Suppose G1 is the gain of the first stage and G2 is the gain of the second stage. The gain of this 2-stage amplifier is G is equal to G1 into G2. If you are calculating in decibel, G is equal to G1 plus G2. Its operation is the AC input signal of the first transistor gets amplified and appears at RC, which is then passed through CC to the next stage. This becomes the input of the next stage, whose amplified output again appears across the collector load RC. The total gain is less than the product of the gains of individual stages. This is because when a second stage is made to follow the first stage, the effective load resistance of the first stage is reduced due to the shunting effect of the input resistance of the second stage. Its frequency response is this one. Here the reactance Xc is 1 by 2 pi Fc. At low frequencies, that is less than 15 Hz, Fc is low, therefore Xc, high reactance of Cc causes very small part of signal to pass from one stage to the next. And due to the high reactance of Ce, emitter capacitor, it cannot shunt the emitter resistance effectively. At high frequency greater than 20 kHz, the reactance of Cc is small and behaves as a short circuit. This increases the loading effect of next stage and serves to reduce the voltage gain. Along with this, as the capacitance of emitter diode decreases, it increases the base current of the transistor, due to which the current gain reduces. Hence, the voltage gain rolls off at high frequencies. At mid frequencies, between 50 Hz and 20 kHz, the voltage gain of the amplifier is constant. It is flat. If the frequency increases, the reactance of the capacitor Cc decreases, which tends to increase the gain, but this lower reactance increases the loading effect of the next stage, by which there is a reduction in gain. Advantages: the frequency response of RC amplifier provides constant gain over a wide frequency range, hence most suitable for audio applications. Its circuit is simple and has lower cost because it employs resistors and capacitors, which are cheap. The circuit is very compact, as we know the modern resistors and capacitors are extremely small and light. The voltage and power gain are low because of the effective load resistance. They become noisy with age. Due to poor impedance matching, power transfer will be low. Application: they have excellent audio fidelity over a wide range of frequency, therefore widely used as voltage amplifiers. And due to poor impedance matching, RC coupling is rarely used in final stages. Transformer coupled amplifier: here a transformer is used to couple between different stages. Its frequency response is this one. The gain of the amplifier is constant only for a small range of frequency, very small range of frequency. The output voltage is the collector current multiplied by the reactance of primary of the transformer. At low frequencies, the reactance of primary begins to fall, resulting in decreased gain. At high frequencies, the capacitance between turns of windings act as a bypass condenser to reduce the output voltage and hence gain. The amplification of audio signal will not be proportionate and some distortion will also get introduced, which is called as frequency distortion. Here the impedance of secondary of the transformer is made equal to the load impedance and primary impedance equal to the output impedance of transistor. For example, this is, suppose NP is the number of primary turns and NS is number of secondary turns. RL is the load here, then effective primary impedance RL prime is equal to NP by NS all square into RL. That's how it is calculated. Its advantage is excellent impedance matching, high gain, no power loss in collector and base resistors, efficient in operations, but it have poor frequency response. Frequency distortion is higher. Transformer tend to produce hum noise. Transformer are bulky and costly. Its application mostly used for impedance matching purpose, used for power amplification, used in applications where maximum power transfer is needed. This is the direct coupled amplifier. The first stage is with a PNB and next with an NPN. There is no coupling, it is directly coupled. Its advantages: circuit arrangement is simple because of minimum use of resistors. The circuit is of low cost because of the absence of expensive coupling devices. It cannot be used for amplifying high frequency. The operating point is shifted due to the temperature variations. It is used for low frequency amplifications, low current amplifications, etc. If we compare the three, RC coupling is used for voltage amplification, transformer coupling is used for power amplification, and direct coupling is used in extremely low frequency amplifications.